So problem 7.4, prove the identities valid only in these specified regions. Okay, so we have three identities regarding the arctangents and the arcsines and things like that. And at first sight, you would maybe not know how to approach this, but then we're given a hint to differentiate the equation and check one point of the specified region. Okay, so what does this hint mean? Well, the thing is that if you call this, let's do the first part, right? If we call this function f of x arctangent of x plus the arctangent of 1 over x is this function is equal to pi over 2 whenever x is greater than 0. That means that f, okay, this is pi over 2, this is a constant. Okay, if x is greater than 0. So that means, in other words, that the derivative of f is going to be 0. Okay, so in order to check this, we have to compute the derivative of f, right? The derivative of x is 1 over 1 plus x squared, and the derivative of the arctangent is 1 over 1 plus 1 over x squared. 1 over x squared times the derivative of this, okay, which is minus 1 over x squared, right? Now let's operate with this. We have 1 over 1 plus 1 over x squared times, okay, this times minus x squared, okay, or we can leave the minus out, right? So if we expand this product, we have minus 1, and then we have x squared that multiplies this, and x squared that multiplies the other thing. This is minus this thing, okay? So this is actually 0. So that's correct. This function is constant. Now, how do we check that it is equal to pi over 2 in this interval when x is greater than 0? Well, we have to find, to check one point of the specified region, as it says here, right? And it depends on, you know, what your values of the arctangent, you know. I happen to know that the arctangent of 1 is pi over 2, right? That's the, sorry, pi over 4, okay? Because that's the let's say, how to say this, the angle that makes the tangent be 1 is actually pi over 4, okay? Half and right angle. Now, if you have f of 1, right? F of 1 is the arctangent of 1, pi over 4, plus the arctangent of 1 over 1, which is pi over 4. So this is pi over 2. Okay? Now let's see if we can do the rest. Okay, let's do part 2. Let's call f of x is the arctangent of 1 plus x, 1 minus x, right? And then minus the arctangent of x. And it says it's pi, it's constant and equal to pi over 4 if x is smaller than 1. Okay, so let's see. In order to compute this, the derivative of f prime, okay, we need to know what the derivative of this is going to be. So we have, let's call this function g of x. This is 1 plus x divided by 1 minus x. And we can rewrite this like this. This is 1 minus x, right, plus x, right? So I've just subtracted and summed x so that we have the same thing in the numerator and the denominator. So this is just 1 plus 2x over 1 minus x, okay? And for me, that's way easier to operate than this, maybe. So g prime is going to be, this is 0, and then this is 1 minus x squared, and then we have 2 times 1 minus x minus 2x the derivative of 1 minus x, which is minus 1, so plus this. And so the derivative of this, we have 2 minus 2x plus 2x, we have 2 divided by 1 minus x squared. Okay? And now we have f prime is the derivative of the arctangent. So this is 1 divided by 1 plus x divided by 1 minus x squared times the derivative of this, which is 2 divided by 1 minus x squared minus the arctangent of x, which is 1 plus x squared, right? Let's operate with this, right? So we have 2, and then this is multiplying this whole denominator, so we have 1 minus x squared, and then we have plus 1 plus x squared divided by 1 minus x squared multiplied by 1 minus x squared, you get 1 plus x squared, right? And then let's see, you have minus 1 over 1 plus x squared, right? Now let's see, we have to expand this product, right? So we have 1 plus x squared minus 2x plus 1 plus x squared plus 2x, and so minus and plus 2x get cancelled out, and you get 2 divided by 2 that multiplies 1 plus x squared, right? You get 2 of this, minus 1 over 1 plus x squared. So this and this cancel out, so you have 1 over 1 plus x squared minus 1 over 1 plus x squared. This is 0. Okay, so this function is constant. Okay, and now is this equal to pi over 4 if x is smaller than 1? Well, we can use f at 0, right? So we have the arctangent of 1 plus 1, the arctangent of 1 minus the arctangent of 0. The arctangent of 1 is pi over 4, the arctangent of 0 is 0, so we get pi over 4, which is what we wanted. Okay? And then look, let's do the last one. 3 is f of x is 2 times the arctangent of x plus the arc sine of 2x divided by 1 plus x squared equals pi if x is greater or equal than 1. Okay, so now let's compute the derivative of this. The derivative of this is 2 times 1 plus x squared, right? And then we have plus, and then the derivative of the arc sine, right, is 1 divided by the square root of 1 minus this thing squared, 2x divided by 1 plus x squared, right? And then multiplied by the derivative of this, which is, let's compute this, the derivative of 2x over 1 plus x squared, we have 1 plus x squared squared, 2 times 1 plus x squared minus, and then we have 2x times the derivative of this, which is 2x, so we have times 2x, right? So this is 4x squared, so this is 2 minus 2x squared if you do the computation, and you have 1 plus x squared squared. Okay, so in other words, this is 2 times 1 minus x squared, 2 1 minus x squared divided by 1 plus x squared squared. Okay, so let's see how we can deal with this. Well, as you can see, wait a minute. So I have 2 over 1 plus x squared, and then this thing I can have plus 2 over 1 plus x squared, right? And then this is multiplying 1 minus x squared, and the denominator I take in one of these two, 1 plus x squared, one of this is here, the other one I'm going to take inside the root, so I have this is the square root of 1 plus x squared squared minus 2x squared, right? Okay, so let's keep doing this. So I have 2 over 1 plus x squared plus 2 over 1 plus x squared that multiplies 1 minus x squared divided by the square root of, and then we have 1 plus x to the fourth plus 4x squared minus 4x squared, right? Sorry, this is not 4, this is 2. 2x squared. Okay? And now this thing here, we have 1 plus 4 minus 2x is the same as saying, in this case, this is 1 minus x squared squared, right? But the thing is, 1 minus x squared, if x is greater than 1, is going to be negative, right? So we take the square root of that, and we're taking the positive square root, but that's what they're telling us. What we're getting is 2 over 1 plus x squared plus 2 over 1 plus x squared times 1 minus x squared, and then we have x squared minus 1, okay? Because the square root of this, taking the positive value, it's going to be x squared minus 2, okay? And so this division is going to be minus 1, this minus this is equal to 0. So that proves that this function f prime is 0, that means that the function is constant, okay? Now how do we check that the function is has actually that value in the interval? Well, this is valid for x greater or equal than 1. Let's try for 1. So then we have 2, the arctangent of 1, that as we know is pi over 4, plus the arc sine of 2 divided by of 1 plus 1, which is 2, or in other words, the arc sine of 1. And the arc sine of 1, what is the value of the sine that has 1? Well, it's pi over 2. Between minus pi over 2 and pi over 2, the value that makes the sine equals 1 is pi over 2. So 2 times pi over 4 is pi over 2 plus pi over 2 is pi, which is what we wanted to check. And that ends the exercise.